right. Hello, guys. Hope you guys are having an excellent morning. Today, we're going to be learning a little bit more about soils. I know you're probably thinking, Miss Warnes, you're teaching us about dirt? Well, I can assure you that soils is a whole heck of a lot more than dirt. So let's jump right on in. Throughout this video, I'm going to have you go back to Google Classroom to watch some other YouTube videos that I've put up. And that's what we're actually going to start with, guys. So go ahead back to my Google Classroom page. There's a link to a video called What's the Dirt on Dirt. Give that video a watch, so go ahead, pause me, head back to Google Classroom, watch that video, then come back to me. Alright guys, I hope you enjoyed that lovely cinematic masterpiece. Alright, let's talk about it. So, soil is a whole heck of a lot more than dirt. The main two parts of soil are inorganic particles and organic matter. Now, inorganic particles are things that are not alive. Things like rock and broken down rock, water droplets, air pockets, and then organic matter are things that are living. So insects, small animals, bacteria, humus, which we'll spend a lot of time on later, minerals, fungi, and small animals. So we've got the inorganic, the non-living, and the organic, the living materials. All right, let's hop back to my Google Classroom page. We're going to watch another video. This one is titled Introduction to Soil Part 1. So pause me, hop back to Google Classroom, and give it a watch. All right, guys, so carrying right on. Let's take a minute to look at some of the organic matter. Let's take a minute to look at the organic matter. So now one of the most important things in soil that we might not necessarily think of is bacteria. Bacteria is absolutely critical to most plants' growth. So if we look at this plant's root down here, this is a ripped up root from a plant, we can see these funny looking bumps on it. Anybody got to guess what those bumps are? So those bumps are called nodules. N-O-D-U-L-E-S, nodules. And those nodules play host to millions of bacteria. Millions upon billions of bacteria. And in those nodules, they help the plant convert certain soil nutrients into other nutrients that they need, like nitrogen. Nitrogen can be found in fertilizer. And the cool thing about these legume plants that have these nodules is they can do what we call nitrogen fixing, meaning they can make their own nitrogen with the help of bacteria. So bacteria don't just make you sick, guys. They can help you out in a lot of other ways. In healthy soil, there's actually more bacteria in 1 teaspoon of that healthy soil than there are people on Earth. Last time I checked, there's about 7 billion people on Earth, if that gives you an idea of how many bacteria are in 1 teaspoon of soil. Another thing we're going to find in our soil is fungi. Similar to bacteria, they have helpful relationships with plants. We can also find insects, so grasshoppers, worms, all kinds of beetles, bugs, and creepy crawlies, and also small animals like mice, snakes, stuff like that. Those animals become important later when we're looking at soil aeration. Big word there, guys, aeration. And finally, humus. Humus is critical. So if we look back at the picture behind all of our words, look up here. We can see the grass, but then we can also see this kind of lighter colored layer right below it. That is humus. Humus is the decaying plant and animals and waste. And what that is a plant's idea of a 5-star meal. That stuff is packed with nutrients. Oh my gosh. So humus is decaying plants and other waste, and it is plant food. You'll find it right above the topsoil layer, which we'll talk more about later. So looking at inorganic particles, we're going to spend a couple of slides on this. Inorganic particles. These are either rocks or rocks that have broken down. So the particles are different sizes, and the different sizes of particles determine the characteristics of that soil. So the largest particles, the least broken down ones, are sand. Like you'd find at the beach, this is sand. The medium-sized particles are what we refer to as silt, and the smallest sized particles are clay, like that red stuff that's always muddy. We're going to learn why it's always muddy. So putting this into scale, if a particle of sand was the size of a basketball, a particle of silt would be the size of a baseball, and a particle of clay would be the size of a golf ball. So these particles are not similar in size at all. There's a dramatic difference between the sand and the clay. Similarly, there's a dramatic difference in what these soils are good at. So large soils like sand, if you think about deserts, they're always dry. And it's not just because it never rains there, it's because any moisture that gets into the sand immediately drains away. So if I had a bucket of sand with some holes in the bottom and I poured a gallon of water on top of it, it would immediately come out the other side. Large particles drain water very, very quickly. On the flip side of that, we can see here this poor person who's stuck in a clay pit. Clay particles are very, very small. They do not drain water very quickly. So if your yard is always muddy, it's probable it has a large amount of clay in it. So our larger particles mean quicker water draining. Smaller particles mean slower water draining. So clay holds water, sand does not. On the other side of that, larger particles have more room for air space. Now, why do plants need air? Why does soil need to be in air? Good question. So plants need air the same way people do. Plants can actually drown if they have too much water and not enough air. So there needs to be micro air pockets. Let's flip to that slide. See here between the sand, we've got these little pockets in between where a plant could get its root and get some air to breathe. Compare that to the clay. There's very little pocket space for a plant to be able to breathe its air. So a larger particle size holds air, but not water, and a smaller particle size holds water, but not air. Everybody with me? That's kind of a hard concept. Rewatch this part if you didn't quite get that. Continuing on. So here's our soil texture triangle. So this is how scientists describe soils. Looking at this big scary triangle, we're going to learn how to read it. And what this is it compares soil samples. So I could bring a sample of soil to the lab and they will tell me this soil is 10% clay and 5% silt and 85% sand. Then I could call up my scientist buddies and say, well, in this area, we have a sandy loam soil. And it would be the same as their sandy loam soil, or they could say, we have a clay loam. And it just makes sure that we're all talking the same language when we talk about soils. So we'll see on each different side, each side has a different percent of clay, sand, or silt. So let's learn how to read it. So the clay percent is over here on this side, and you read it straight across to the right. So 60% goes straight across this way. 40% goes straight across this way. Silt is over on this side. Silt can be read down. So silt are these down-facing lines. And finally, our sand are the lines that slope up and to the left. Sand is up and to the left. So let's try a practice problem. So we have 60% silt. Let's find silk. So 60% silk, here it is. And silt gets read like this. We drew a nice line in right there. Silt gets read going down and to the left. So we have our silt line. It is 20% sand. So let's find the 20%. So that's going to be this line right here. And finally, it is 20% clay. So 20% clay would be this line right here. And clay is read going straight across. So where all three lines intersect is the type of soil that we have. So we have a type of soil that is called silt loam. Silt loam. All right, let's try a few other ones. All right, so this one is going to be 40% silt. So we're going to read that down going this way. 40% silt. 55% sand, so that'll be between the 50 and the 60. So 55% sand, we'll see that line right in here. And 5% clay. Very small amount of clay in the soil. Okay, so where the lines intersect is what it's going to be. So it is going to be called a sandy loam. Sandy loam. All right, another practice one to do together. So this one is going to be 8% silt. So we're going to come up here to silt, and it's kind of going to be in here, just below, between the 10. So imagine my mouse is 0 and this is 10. So it's going to be right in here. 8% silt. Let's come down here to sand. 32% sand. and 60% clay. So we'll come up here to the clay line, right here. Boom. So this type of soil would be called clay. Just clay. All right, so here are some practice problems for you to work on your worksheet. Go ahead and hit pause on me until you work these out. So hit pause on your table. You have some soil texture triangles. Get out a ruler, get out a highlighter, get out whatever you need to get out, and let's map out what these problems are, okay? All right, guys, let's switch gears a little bit now that we're done with soil texture. We're going to take a little look at soil erosion. I'm sure you've heard about this in your science class, but we're going to look at it from an agricultural perspective. So hit pause on me, and then go watch the video in Google Classroom called Let's Talk About Soil. Dun dun dun. Okay, so that video was very doom and gloom, wasn't it? Wow. So soil erosion is a major problem. It takes over 500 years to form a single inch of topsoil, meaning since the time Christopher Columbus got his butt over here, we have only made an inch of topsoil. Yeah, the only thing between you and Columbus is an inch of topsoil. So agriculture requires 6 inches of topsoil, so 3,000 years of soil. That's kind of crazy. The problem is we're losing soil at a rate of 10 to 40 times faster than it's being created. So now you're probably thinking, Miss Warrens, who is stealing our soil? It's not like the Martians are coming down here and scooping it up. Yeah, no, they're not. We're actually stealing it from ourselves, which is a major problem because 90% of the food we eat is grown in soil or connected to soil directly in some way. Now, I don't know about you, but I'm not about to cut out 90% of my diet when we erode all of our soil. So let's learn a little bit more about the causes and how to prevent it. So soil erosion, the main ways that we lose soil is through wind and through water. Wind will blow it away, or water will carry it away. And the areas that are most prone to this are areas without some kind of crop or vegetative cover. So plowed fields, stream banks without vegetation on them, stuff like that. Where we tend to see that the most are areas in third world countries where they don't have very advanced agricultural techniques. You can see on this hillside over here, the land is just bare, guys. I mean, every rainstorm that comes through is going to whisk topsoil off this hill. And then that causes that area to be less fertile. Those people get less and less food from that patch of land, and it's a vicious cycle of these people being trapped in poverty. They don't have the money to know how to get the education, to know how to keep their soil there. They get less and less food, so they get poorer and poorer, and it's a cycle. It's awful. All right. So another place that we tend to lose a lot of soil is crops that are fields that are tilled. So after we chop the corn for the year, some fields in this area sit bare, and every time we get a snowstorm and the snow melts, that soil gets whisked away, and we don't get it back. Or anytime a good breeze comes through, it'll blow some soil away too. I forgot to put it in the bullet points, but another place that we're going to see a lot of soil erosion are in areas like where these Hereford cows are. We can see this muddy stream bank. Every time the cows come down, they carry soil into the stream with their hooves, and then that soil gets washed away, never to be seen again. We're also going to see a lot of erosion here in these construction zones. In order to build anything, you have to get rid of all the grass and trees so you can put down asphalt and such. But every time a good wind or rain comes through here, this construction zone is just going to lose tons of soil. So why is this an issue beyond us not having soil to grow our food in? That's our main issue, but another issue that we're going to see is sedimentation. So sedimentation is when a river has more soil in it than it can actually move. So the soil settles to the bottom of this river, like we can see in this picture on the right. This river has a lot of sedimentation going on. And some consequences of this is reduced habitat. The animals, all the rocks on the bottom of the river have soil all around them, so the animals can't use those rocks as a habitat anymore. The rivers are more prone to flooding because they're filled with dirt. They can't fill with water, so you're going to get more flooding, which increases erosion, vicious cycle. You're going to get muddy streams, which are not good to look at. You can't drink out of those. If you're in a third world country and you're relying on a stream as your water source, you're out of luck. There's decreased recreational value. I don't know about you guys, but I wouldn't want to take a vacation to this river. And there's also structural damage from all of this. If we have more flooding, we can damage our roads and our buildings and stuff like that. So sedimentation and soil erosion are huge problems. So let's look at some ways we can prevent it. The number one reason we get soil erosion is because our soil is naked. Yeah, I said naked. Look, you don't like walking around naked, and neither does our soil. Our soil needs to be covered up. It needs to have plants on top of it. So farmers can help by doing cover crops. So looking up at this picture on the top right, we can see that this farmer has done two things really well. Number one, he's planted a cover crop, which is this grass-looking stuff. This is something called winter rye. And the plant's roots are holding the soil in place, keeping it from being blown or washed away. Another thing this farmer has done really, really well is he's practiced no-till farming, meaning, see these corn stalks? We refer to that as corn fodder. He has not come through and disked that fodder under. The less you have to disk and till and plow and generally mess with the soil, the better, because every time you mess with it, it gets exposed. The best thing we can do for our soil is just leave it be when it comes to farming. Another thing you can do is if you're working on something in your yard that ends up exposing the soil, is you can put straw down to encourage the grass to grow back and to help hold the soil there temporarily. And finally, if you have a farm, you should fence your animals out of your streams and your ponds. Guys, it's 2017. There's no reason for animals to be in creeks and ponds anymore. This is honestly a huge issue from a lot of ways. Number one, it increases soil erosion, but number two, the cows poop in the stream, and that contributes to a lot of problems out in the Chesapeake Bay, which we'll learn more about later. All right, continuing on. Oh, looks like we've reached the end of this slideshow, guys. So go ahead, hop to the next video, Miss Warren's Part 2. Hope you've enjoyed Miss Warren's Part 1.